Now the worst and the last case we're going to consider is this quadratic times quadratic with all the coefficient in there, and they're not equal to each other. So it's going to look like this. So here's how it looks like. The first factor is quadratic, and second factor with all the coefficients written in different indices and so on. So I'm going to introduce a little notation to kind of write down this coefficient in a better way. In two-dimensional way, that's what I say. So I'm going to use this notation just for this one. I think it's a convenient one. If I have A, B, C, D, if I write it like this, the bracket, it happened to be the matrix notation, but just for this problem, we're going to write it like this, and we mean AD plus BC. It's more confusing if you know what is called the determinant of 2 by 2 matrix, but it's just a notation that rises here. I think it's convenient to write it like this. It's less confusing. So if I use this notation, and I'm going to use another notation, but I will introduce it in here because that only shows up in one time. So here we're going to write A and A2. That's the x to the fourth. I guess this is the only thing that I'm going to use. I'm just going to use this one here. A1 times A2, that's the coefficient of x to the fourth, and here's that notation. So let's think about the coefficient of the third power. Third power is coming from squared multiply to that first power of x, and this A2 squared multiply to the first power of that one. So I wrote A1, A2, these are the square power, and the first power is a B1, B2, if I write it underneath it, and then if you cross multiply, of course, you get all the third power there. So let's think about second power. Let's trick in here. So x to the second power. First of all, you get multiplying this part to the constant part, and that constant part there to the square part. So you write down the coefficient of a square thing again, and the constant part in C1 and C2. But that's not the only way to get x squared. If you multiply x and x there, that's another possibility. So I wrote it here. Maybe I already in that situation. I wrote it like this. If I separated what we mean by B1, B2 here is a product of these two things and multiply by that. So let me erase that part. Does it look like C2? Let me write it again. So here's the C1, C2 in there. All right? So again, this means B1 times B2. Now let's think about the coefficient of x. There's not much possibility for x part. X is multiply the constant. That's the only part. So B1 and C2 is down there. And this B2 multiplied C1, P2 here and C1 there. So cross multiplication. And the constant part is, of course, is easy, C1 times C2. So that's how it's going to expand, meaning that this bracket is this cross multiplication with a positive sign in there. So next part goes like this. First we look at the leading coefficient and the constant part. Just like the quadratic factoring quadratic polynomial, we're going to factor the leading coefficient and the constant coefficient. With that possibility, there are many possibilities. Given that possibility, A1 and A2, C1 and C2, we have to figure out what's going to happen here. So if you look at these first two coefficients, A1 and A2, C1 and C2, is kind of determined at this intermediate stage. And since here A1 and A2, C1 and C2 are known, only thing that is not known here is B1, B2. And you can see from here we have B1 and B2 because A1 and A2 is known. So we have A1, B2, A2, B1. So that part is known as capital B. That part here, we have B1 and B2. So B1, B2 plus this part is known at this stage. A1, let me write that again here. A1, C1, C2, A2, C1. So that's a capital C. So with A1 and A2 and C1 and C2 known, and we have to determine what B1 and B2 are, that satisfy these two relations. And that is going to end up at some quadratic equation because the way it's written, sum and product known, and so it's going to end up at quadratic equation for figure out the B1 and B2. Now once you figure this out, and whatever the possibility, for example, this quadratic equation we're looking at for B1 and B2 might not have rational zeros. In that case, we stop there. It's not possible to have the rational coefficient like that. If this B1 and B2 turned out they are rational, then everything is determined. Every A1 and B1 and C1 and same coefficient, the other factors are determined, and therefore we just have to multiply out and hoping that this part is recovered. If not, we have to move on to the next possibility. So I guess there's no point of memorizing these formulas, and it's not going to be that often you will encounter it anywhere in learning mathematics. So it's just this principle. The case is not that so many, but by just considering just a few cases, we can figure out what these are. So rather than just trying to memorize this formula just for the exercise we're about to go through, let's just stick to this principle here and figure out each of the step and prove it along the way. So here's an example. I chose example, and this is a nice case such that we don't have to worry about too many possibilities. For the leading coefficient case is just a 1, so that's only the possibilities we have to think about is how to split this 1 and 5 into a 1 times 5 and -1 times -5, things like that. So here's how it goes. That I'm going to call that polynomial f of x. This is f of x equals. So the first possibility we're going to consider, here's I'm going to call the B1 and B2, C1, C2. Slowing down, so I'm going to redo it. So here we go again. So I'm closing, and x is squared. And B2, you just have to determine what those B1 and B2 are. Now, if you think about the possibility of splitting 1 and 5, one possibility is 1 and 5. If this doesn't work, of course, we're going to do -1 times -5. It's more involved than just factoring quadratic polynomials, so going through this way, I think it's better. So let's just go ahead and expand what those are. So x to the 4th. The coefficient of x to the 3rd is coming from multiplying like this, b1 and there, b1 times x and x squared, and b2 times x squared here, so b2 and x to the 3rd. And that's the only way to get those things. Let's think about the square case. How do we get x squared? You can multiply there as a 5, and you can multiply 1 to x squared. That will be just 1. But you can also multiply b1 and x times and x in here. So that will be b1 times b2. So as you can see, this will already determine what this b1 and b2 is going to be, because that had to match 3 and that has to be 8. But let's move on. So what about the coefficient of x? And x is 5b1. So here's 5b1. I think that's how you get x. And the other part is b2. It's b2 here. That's x, and constant is 5. This must be the original given coefficient. So we have this b1 times b2 equals 3, and plus b2, and b1 times b2, that have to match 8 here. Alright, let me do this part, the second part again. This what we see in front of x squared, here the 6 plus b1, b2, and that entire coefficient must match the coefficient in front of x squared, so that's 8. So that's equal to b1 times b2, equals, here's 2. All right, so you can substitute b2 is a 3 minus b1 in here and get a quadratic equation in b1, or vice versa. Sometimes you will have some coefficient in front of b1 and b2. So that will be some elimination method you go through, and then you end up at some quadratic equation. Here I think it's easy. 1 and 2, it does it. And often because if it works, I'm sorry, let me write that down. If it works, it's going to be an integer solution, so unless the number is too big, it's kind of in front of us, right in there. So 1 is 1, and b2 being 2. Where you put b1 and b2 in here, 1 and 2, I think it matters. So it is important to consider both possibility like this, because it's not symmetric. 1 is there and 5 is there, and this is something that you have to figure out along the way. You have another possibility to take care of here. So let me continue over here in this space. So things that these are the possibility for the case where we split it at 1 and 5 in here. And so the first case to try is at x squared plus where b1 is 1 and b2 is 2, x plus 5. And another thing to try is at x squared plus 2x plus 1 and x squared plus x plus 5. So that's another thing to try. This actually factors nicely, and if this were the case, we would have picked up earlier, and then, well, you don't usually do this one. At first, you try the rational zero theorem first, so that would have caught in there. So if you actually expand this one at a time, which I won't do, turns out this guy is actually exactly this one expands to this polynomial, and this one is not. But maybe after this try, none of this thing worked, then you should go for another factorization possibility of leading coefficient and a constant part. And the next step would be, if these guys didn't work, and will be the considering the following factorization, where another factoring is -1 times -5. Putting 5 there and 1 is there, because b1 and b2 is unknown. You can see that 5 in here and 1 is there. It's kind of the same. You will just have different order of considering b1 and b2 here. So meaningful consideration here is really this opposite sign, like this x squared minus b2x and plus b2x minus 5 in here. Now when you go through this, that you will have a maybe slightly different arrangement, and from here maybe you're going to pick up factorization of 2 quadratic over the rational coefficients. So this is a case where leading coefficient is 1. It's a monic case. The case this one is not monic is just like this. It's just more possibilities kicks in there. So we'll consider an example. Right, this is the second example of this worst case thing. As you can see, the coefficient of x to the 4th is not 1. So we have to consider the possibilities of all factorization of these leading coefficients and the constant term. So let's consider the first possibility, f of x. I will definitely consider 1. Sorry about this, x squared. This is supposed to be x squared. So it's x squared and b1x and plus, and this one definitely consider 1 and 5. 1 and 10, so x squared. Sorry about this. Keep getting the wrong one. So this is going to be 6x squared plus b2x plus 10x. 10 here. So that's the first possibility. That matches the product of these two things become the leading coefficient. Product of these two things is the constant coefficients. So let's expand this one. Since we have done that, it's going to be exactly the same procedure. So I will skip that part, and you may pause the video here and do that part yourself. Okay, here's when I did it, the coefficient of x to the third is 6b1 plus b2. Coefficient of x squared is a 6 plus 10 plus b1, b2. Coefficient of x was 10b1 plus b2, and plus 10 was a constant. So that part here is the same as 16 plus b1 and b2. Alright, let's compare the coefficient of x to the third and x squared here with what is known, what is given there. So what we have here is a system of equation for b1 and b2. 6b1 plus b2 should match that coefficient 1. And this one here is a 16 plus b1 times b2 is going to be 18. So here you can easily see the b1 times b2 is going to be positive 2. So what we're looking for here is integers, b1 and b2. So there are not many b1 and b2. We can consider that become 2. So here 1 times 2, 2 times 1, because it's different order matters here, or negative 1 times negative 2, or negative 2 times negative 1. These are the possibilities. So if you look at 1 and 2, there's no way that with a negative number it's going to be a 1 like this. With this both negative number, there's no way it's going to match it. You can easily see that there's no integer solutions. Like this. Even if we find integer solutions, we have to plug it in here, check with this third coefficient to check. So I forgot to put in here. Let me go ahead and fix it. This is supposed to be 6. Sorry about that mistake. 6 times x to the fourth. So we have to move on to different possibility of factoring these two coefficients in there. So you keep repeating until you hit maybe you try all the possibility and none of them worked. Then you can conclude that the given polynomial does not factor to two quadratic like this. So I'm pretending we went through many cases here, so we don't know which cases we're considering here. But here's one case. We arrived at 2 and 3. That's how I split it. The 6 and 10 is split as a 5 times 2. Again, it's not symmetric, so if you put 2 and 5 here, it really a different case, so you have to proceed on that one too. So suppose, and if I split it like this, see what happens. So first of all, we can have x to 6 times x to the fourth. Like before, I want you to pause the video and do this part yourself and compare your answer with mine. Okay, these are the coefficients I have. The coefficient of x to the third is a 2b2 plus 3b1. Coefficient of x squared is 19 plus b1 plus b2. Coefficient of x is 2b1 plus 5b2, x plus 10. So next step, of course, is going to compare. We're going to compare this one with the coefficient of x to the third and x squared. So this coefficient of x to the third, 2b2 plus 3b1, is going to be 1. And coefficient of x squared, 19 plus b1, b2, is going to be 18. Like we did before, we're going to solve for b1, b2 first. That will be negative 1. And with this possibility, there are not many possibilities for two integers multiplied to negative 1, namely 1 and negative 1 here for b1 and b2, negative 1 and positive 1 for b1 and b2. So which way it's going to be? It seems like we want this thing to be positive 1, that thing to be negative 1. So easily concluded here, b1 must be 1 and b2 must be negative 1, and that will be the only pair of b1 and b2 that satisfy this condition. Now we have this b1 and b2, of course that will satisfy these two coefficients there. It's coefficient of x to the third and coefficient of x squared, and that's what this is. If these together with this solution b1 and b2 also make this one exactly the same as negative 3, and that'll be the factorization. So let's go ahead and try this coefficient right here with b1 equals 1 and b2 equals -1. That's what we have so far. b1 and b2 is the only thing that we have to determine, but if you calculate it, there's 2b1 plus 5b2 up there is 2 times b, so 2, and that's -5, and it is -3, and that checks with a coefficient there, coefficient of x in the original polynomial. So here the coefficient of x in being -3, and that's what we are checking it there. So we have found the factorization. Answer for this factorization is 2x squared. b1 was 1, so x plus 5 times 3x squared. b2 was -1, so it's -x plus 2, period. And these product of these two polynomials will be the factorization of this quartic polynomial. Thank you.